Now, hello, come to our next point on behavior of conductor in electrostatic. Electrostatic field just outside the conductor is perpendicular to the surface of the conductor. Mean electric field is always perpendicular to the surface. This we have to prove now. So this we can prove by considering let electric field make any angle with the surface of conductor. Suppose here we have a conductor and electric field make any angle. Let it make any angle with the surface of the conductor. Let this is the electric field and it make angle theta with the surface of the conductor. So now this electric field can be resolved into two components. So one component is that is along the surface of this conductor. We can say that this is the tangential component that is along the surface of conductor, and that is equal to E cos theta. And second component that is perpendicular to the surface of conductor, E sin theta. This component is perpendicular to the surface of a conductor. Now this tangential component of the electric field that is along the surface, that is along the tangent of the surface, we can say that along the tangent, and on the surface of the conductor there is charge. So this component of the electric field will cause the charge to move. This component of the electric field will cause the charges to move, because this component will apply the force on these charges, and due to that force these charges would move, and due to the motion of these charges on the surface there is what surface current. You know that when the charge will move then there is a current, but it is observed that when the conductor is placed in the electrostatic there is no surface current, because the conductor is placed in electrostatic and we are dealing with the static charge. That is tangential component, that is E cos theta, would apply the force on the charges on the surface of conductor and cause surface current, but there is no surface current because conductor is placed in electrostatic. Electrostatic means charge remain at rest. So we can say that E cos theta component that is equal to 0. So E not equal to 0, electric will never be 0 because that is placed in the electrostatic field. So cos theta that becomes equal to 0, and so theta is equal to 90 degree. And theta is the angle between the direction of the electric field and the surface. When the theta becomes 90 degree, so electric field is like this. Electric field is always perpendicular to the surface. Electric field is always perpendicular to the surface. So we can prove that electrostatic field, when the conductor is placed in the electrostatic field, electric field is always perpendicular to the surface. In this way we can prove this. Now come to our next behavior of the conductor in the electrostatic field. So next is electrostatic potential is constant inside and outside the surface, on the surface of the conductor, and we can say that surface of conductor behave like equipotential surface. Now we will prove this. So suppose here we have any conductor, and you know that inside the conductor net electric field is 0, charge also is equal to 0. Now we have to prove about the electrostatic potential. Now because we know that E is equal to minus dV upon dr, we are going to prove inside the conductor. E is equal, because E is minus dV upon dr, so inside the conductor electric field is 0, so we can write dV upon dr is equal to 0. So because the constant, the derivative of constant quantity is equal to 0, so inside the potential that remain is equal to constant, potential that remain constant. Now come to on the surface, or we can say that along the surface, not on, we can say that at the surface and along the surface. The tangential component that is equal to 0. So dV upon dr that is equal to tangential component that is equal to 0. The V also is equal to constant. So we can say that throughout the volume of this conductor, the electric potential that remain constant. So we can say that the surface of the conductor that be like a equipotential surface where the potential remain constant throughout the conductor, inside as well as outside the surface of conductor, that potential remain constant. So I think this video very useful to you. Thank you.